Hello and thank you for watching this video. Please don't forget to like, share and comment on the video, as well as subscribe to Good Better Best online videos for more video content. Hi there everybody. I hope that you are well. Today we are going to be working through November 2023 paper 1, the functions questions. So the first question we are going to look at is question 4, and here it says that we need to write down the equation or the asymptote of f. We can take that straight from our drawing, straight from our equation. The equation says that it is -4, and so we can go ahead and say y is equal to -4. Determine the coordinates of b. Let's have a look at b. b is the x-intercept of fx. And how do we find our x-intercept? We let y equal to 0. So we are going to say 0 is equal to 2 to the power x minus 4, and then we are going to solve for x, and we see that x is equal to 2. The next question says that we need to determine the equation of k, a straight line passing through a and b, in the form kx is equal to. So what you should see is that we've already found b in the previous question. The x-intercept was 2 and 0. What we need to do now is find our y-intercept. And how do we find our y-intercept? We let x equal to 0. So that's 2 to the power 0 minus 4, and that gives me -3. Now we can say y is equal to mx plus c, substituting what we've got. We've got the y-intercept, so we substitute for c, and you'll see there we said it's -3, and now we substitute the other point we've got, which is 2 and 0, and we substitute for both x and y to determine the equation of that line. So here we see that m is equal to 3 over 2, and our equation therefore is y is equal to 3 over 2x minus 3. Right. Let's look at the next question, 4.4. They ask us to work out the vertical distance between k and f at x is equal to 1. So what's important here are the words vertical distance, and you are looking at x is equal to 1. This means that we are going to need to substitute that 1 into both k and f and see what our corresponding y values are. So we'll see that our corresponding y values for f, it's -2, and for k we see that is -3 over 2. So we need to say k of 1 minus f of 1, and that will give us our vertical distance. And we'll see on the next page that our vertical distance is, we'll see that our vertical distance is a half. Let's look at the next question. They say that we need to write down the equation of g if it is given that gx is equal to fx plus 4. Let's write down gx. Gx is equal to 2 to the power x minus 4. And what did they instruct us to do? We need to add 4 to the equation. -4 plus 4 will cancel each other out, and we'll see that the answer is 2 to the power x. Let's look at 4.6 now. 4.6. What we need to understand about 4.6 and inverse functions is that the domain of the inverse is equal to the range of the original. So the domain of the inverse is equal to the range of the original function g. So we need to find the range of g. So we see that the range of g is 1/4 and 16. But how did we find these values? Well, what we needed to do was substitute our restrictions. We have -2 and we have 4 as a restriction. And when we substitute this into the equation, we'll see that we've got 2 to the power -2, which is 1/4, and 2 to the power 4, which is 16. So this gives us the range of g. And now the domain of the inverse will be the same, which is 1/4 and 16. 4.7 says that we must write down the equation of the inverse in the form y is equal to. So we see our original equation is 2 to the power x. The inverse would then be x is equal to 2 to the power y. Okay, but we can't leave it like that because it's not in the form y is equal to. So we need to get it into that form. And how do we do that? What we are going to do is write it in log form. So we have log x is equal to, that exponent will become a coefficient. So it becomes y log 2, and we divide by log 2 on both sides. Why do we divide by log 2? Because if we do that, it will cancel on the right-hand side, leaving us with just y. So we've isolated the y. So we have y is equal to log 2 to the x. And that's your answer. Okay, so let's have a look at question 5. Question 5.1, they ask us to write down the coordinates of the turning point of F. And here we can take that straight from the equation. It's going to be 1 and positive 8. 5.2, they ask us to write down the coordinates of C. C is the y-intercept of the parabola. How do we find our y-intercept? By making x equal to 0. And this is what we've done here. So we said 0 minus 1 squared, and that gives us a y-intercept of 7.5. Did we answer the question? No, we didn't. We found the y-intercept, but they are asking us for both coordinates. So let's not lose our marks. We need to write down the coordinates, and the coordinates are 0 and 7.5. 5.3, they ask us to calculate the value of d. Now, what we need to take into consideration here is that this hyperbola doesn't have a p and a q value. So what we need to do is, we have gx is equal to d over x. All we need to do is substitute a point on the line, and we have 1 and 8 as a point on the line because it intersects with the parabola. So we substitute 1 for x and 8 for y, and we see that d is equal to 8. And so gx is equal to 8 over x. 5.4 says write down the range of g. How are we going to write down the range of g? G is the hyperbola, and we know that generally it cannot, so your y value cannot be equal to your asymptote, but your asymptote in this case is 0. So we say y is an element of R, but y cannot be equal to 0. Now we have 5.5, which says for which values of x will fx times gx be less than or equal to 0. So guys, you might have your own way of answering this question. I like to divide my graph into sections. So how do I decide what the sections are? Normally what I do is I look at the intercepts, and I see there's an intercept at -3, and then I look at my 0 value. Here I look at another intercept. Okay, so what I'm doing now is I'm going to be looking at what the values of the graphs will be, whether it's positive or negative, in those particular sections. If I look at section 1, the parabola is negative and the hyperbola is negative. A negative times a negative is a positive. Then I look at section 2, which is between -3 and 0. And here I say the parabola is positive, but the hyperbola is negative. A negative times a positive is a negative. In section 3, I say that's between 0 and 5. Both graphs are positive, so a positive times a positive is a positive. And then in section 4, which is all values greater than 5, I see that the hyperbola is positive, but the parabola is negative. A negative times a positive is a negative. So this tells us that the function must be less than or equal to 0. If I look at a negative times a negative, that's a positive. This value, section 1, must be excluded. Section 3 must be excluded because it's also positive. Less than 0 implies that the graph must be negative. And so here, a negative times a positive, section 2 will be included, and section 4 will be included because both of those are negative. So in other words, between negative 3 and 0, the graph will be negative, and for all values greater than 5, the graph will be negative as well. So now we can say x is greater than and equal to, okay, please don't forget to include that equal to because it's included on top here, and x has to be greater than equal to 5. Okay, let's look at the next question. Okay, so let's look at 5.6. So guys, if we look at the hyperbola, which is our gx function, they say calculate the values of k, there's k, so this is a straight line graph, will not intersect the graph of g. So this means that these purple lines that you see, the graph that we draw will have to lie in this interval here, in that canal, between those 2 points. That's where the graph will need to lie so that it doesn't intersect our graph of gx. I like to draw what they are saying so that I can visualize what they are saying. And now they're saying that the value of k must be such that it does not intersect the graph of g. So now we need to look at those points where it will intersect. So what we're going to do is we're going to say, okay, well, hx is equal to negative 2x plus k, and gx is equal to 8 over x. And what we're going to do is we are going to make those graphs equal to one another. You are going to say to me, but when we make graphs equal to one another, that calculates points of intersection. And that is absolutely correct. We want to find out where would those points of intersection be so that we can find out what it shouldn't be. I hope that makes sense to you. So what we do is we get negative 2x squared plus kx minus 8 is equal to 0. And what we do is we're going to use the discriminant b squared minus 4ac to calculate possible values for x. And we see k is equal to positive or negative 8. So when k is equal to positive or negative 8, this is where the graphs will intersect. However, when k is greater than negative 8 and less than 8, the graphs will not intersect. Now 5.7 goes on to say that h is a tangent to g at r, a point in the first quadrant. Calculate t such that y is equal to fx plus t intersects at r. What does this mean? Is that now they are looking for that point of intersection. So we have hx is equal to negative 2x plus k, but remember we found out those points of intersection. It's either negative 8 or positive 8, but they said it's a point in the first quadrant. So it cannot be in the third quadrant. It has to be in the first quadrant, and therefore in the first quadrant we know that the value is positive 8. And so therefore we say negative 2x plus 8 is equal to 8 over x. And what we are going to do now is we are going to solve for r. And once we solve for r, we see that x is equal to 2. When we substitute, we see that the corresponding y value is 4. So what they are actually asking here is, what do you need to do to your fx graph so that it also intersects at r? It intersects your g graph at r. And so in other words, we are going to be dropping that parabola graph down slightly. And they want to know what you need to drop it down by. So what we are looking at is we're saying, okay, well, y is equal to fx plus t. What point does it need to intersect? It needs to intersect the r value, which we worked out to be 2 and 4. So we substitute 2 and 4 into the equation, and we get 4 is equal to 15 over 2 plus t, and we see that t is equal to negative 7 over 2. So that's the end of the functions questions of this paper. the 2023 November paper. The next section I will be covering will be the calculus. So please have a look out for that video. Don't forget to share, subscribe, and don't forget to like this video. Leave your comments, and we'll see you again soon.